Today's lesson is about exponents and how we work with exponents, what exponents mean, and then also introducing the idea of negative exponents. All right, as a review, exponents are a representation of repeated multiplication. And we can use it as a shortcut so we don't have to write out the same numbers over and over and over again. So for example, if we had 4 times 4 times 4, instead of writing that out, we can use the shortcut where we would write it as 4 to the third power. In an exponential equation, the big number is called our base, and then the small number is going to be considered our exponent. And we would read this as x to the nth power. As a side note, there are a couple of exponents that have special names for them. For example, if we had x with a little 2, we would say this is x squared. And then if it was an x with a 3, we would call this x cubed. So if you think of like a square is a 2-dimension and cubes are 3-dimension. So x squared is the number twice, x cubed is the number 3 times. We are not going to go through all of these examples, but we are going to touch on just a few of them. So here the expanded notation is 11 times 11. That would become 11 squared or 121. For the most part, you're going to use a calculator to evaluate some of these, especially like 11 squared, you might know. But here with all these 2's, this becomes 2, and we would count it out. We have 1, 2, 3, 4, 5, 6, 7. So it's 2 to the 7th. I could use a calculator, and I could use the keystrokes either 2, and then the little button that looks like a rooftop, and then a 7, or you might have what looks like the YX button, and then the 7. Those are probably the 2 most common calculator keystrokes you could use. And if we did that, that would end up being 128. Probably the most common mistake I would see is that students will do 2 times 7 and get an answer of 14. But remember, we're doing that repeated multiplication, so the growth ends up being a lot faster than just 2 times 7, which would be like repeated addition. When we have negatives, it's going to work the same way. It's going to be negative 5 to the 4th power, which means negative 5 times negative 5 times negative 5 times negative 5, which gives us an answer of positive 625. And that comes from the fact that we have that even number of negative signs. On a side note to go along with this one, notice in this problem and the way that I wrote it with exponents, the negative 5 is inside those parentheses, and then our exponent is on the outside. If you were to see an example like this, what this means is basically the opposite of 5 to the 2nd power, or negative 1 times 5 to the 2nd power. So this is evaluated slightly differently, as we would do the exponents first. So we would do 5 times 5, which would be 25, and then we multiply it by that negative 1 in the end. So this one ends up being negative 25. So it is important to pay attention where that negative sign is when it comes to exponents, because if it's outside the parentheses, then it comes afterwards. If it's inside the parentheses, then it's part of the exponent. We can also use exponents to help express fractions. So here we have the repeated multiplication of 1/4. That is going to become 1/4 to the 3rd power, which would end up being 1/64. And if we had multiple numbers that were being multiplied, we would just use exponents for each individual part. So 7 times 7 is 7 to the second power times 4 to the third power. So when you evaluate that, it would end up being 49 times 64, and that would end up being 3,136. All right. If you want to do the next ones on your own, just as kind of practice, you definitely can. Just so that you can check, this would end up being, and the order doesn't necessarily matter, negative 2 to the third times 8 to the fourth, which is negative 32,768. This would be 2/3 to the second times 9 to the second. This ends up being an answer of 36. We can also use exponents with variables. So here our base would be a, and then we'd have 1, 2, 3, 4, 5, 6, 7, 8, 9. So it becomes a to the 9th. And without knowing the value of a, we can't find a value for that problem. If there's two exponents written together, then this becomes xy, 1, 2, 3, 4, 5 to the 5th. And then same thing, kind of jumping down. Here we have that p minus 2 in parentheses to the third power. And then on that last one, we have a plus b to the second power times 6 to the third power. And then that one we could simplify because we can do 6 to the third, so that'd be 216 times that a plus b to the second power. And in 8th grade and further on, you will learn how to actually use exponents and simplify when you have an expression inside of parentheses that has an exponent on it. So kind of moving on, another important thing to know is the idea of a zero exponent. So with a zero exponent, on any number except 0, the value is always going to be 1. So if we have 1 to the 0 power, it's 1. If you have 2 to the 0 power, it's 1. 3 to the 0 power, 1. 4 to the 0, and then x to the 0, as long as x is not actually equal to 0. And then with a negative exponent, it doesn't make the value negative. What it actually does is it gives you a reciprocal, and it flips your number over to its reciprocal. So if it's x to the negative n, this is the same as 1 over x to the n power. So let's look at a couple of examples. If I have 5 to the negative second power, that really means 1 over 5 to the second power, which is the same as 1 over 25. 9 to the negative 1 is going to be 1 over 9 to the first, which is really just 9. 10 to the negative third power becomes 1 over 10 to the third, which is 1 over 1,000. Not going to go through all of these, but kind of just giving you an example. 4 to the negative 3, this would become 1 over 4 to the third times 1 over 7 to the first, which would be 1 over 64 times 1/7, because 4 to the third is 64. We would multiply across, and this would end up as 1 over 448. Like I said before, it kind of works the same thing with exponents. So even though this is x to the negative 9th, this becomes 1 over x to the 9th, and that's all you'd be able to do with it. With 23, when it's 3 to the 4th, that's a positive exponent, so it would stay that way. But then it would be times 1 over 9 to the second. So we kind of think about it as at 3 to the 4th over 1. And 3 to the 4th is really 81 over 1 times 1 over 81. So on this one, when we multiply across, we'd have up with 81 over 81, which would just give us a value of 1. And then this last one with just the variables, this would be 1 over r to the 6th because of that negative 6. That s to the 0 is just 1, and then it's going to be t to the 11th which is going to go over 1. So we would simplify this as t to the 11th over r to the 6th. Feel free to work on the other ones as extra practice, as you're kind of just looking through with those negative exponents, but remembering that that negative exponent just gives us the reciprocal of that original value.